Hello everyone, Ramya, Assistant Professor of CSE Department from Rohini College of Engineering and Technology, subject code CS3452, Theory of Computation, Unit 1, Topic, Finite Automata with Epsilon Transitions. Objectives: to understand the concepts finite automata with epsilon transitions, to analyze the problems of finite automata with epsilon transitions. Finite automata with epsilon transitions. An informal statement of epsilon non-deterministic finite automata using transition diagrams followed as a label. In the examples, think of the automaton and accepting those sequences of label along path from the start state to an accepting state. Here, each E along a path is invisible J, that is, it contributes nothing to the string along with the path. Here, in this diagram, it shows that accepts decimal numbers consisting of 2, a string of digits. Here we are using the operators plus and minus. Decimal point 0 to 9. Another string of digits, either the string of digits or the string can be empty, but at least one of the two strings of digits must not be non-empty. Next, we are going to see finite automata with epsilon transitions. That means epsilon NFA short form. Here also a non-deterministic finite automata with epsilon transition is a 5-tuple Q sigma Q naught dou F. Here Q is represented as the finite set of states. Sigma is a finite alphabet of symbols. Q naught belongs to Q is the start state. F subset of the Q is the set of the accepting state. Here dou is represented as the transition function. That means just consider the two states Q1 and Q4. For the input string, you are going to give 0 and 1. How the states travel from one state to another state. Here the transition function on a string means it accepts all set of states that machine can be done in the possible path on input. Here also we need to consider all paths that include the use of a epsilon transitions. That epsilon means the transition function on a string. It is useful to first define what is known as the epsilon closure. That means it is a set of states X. The epsilon closure will give the set of states reachable from start state to and the epsilon transition. The epsilon closure denotes as E closes is given for each state P belongs to S, that means P belongs to epsilon closure. No other elements of Q are in the epsilon closure. Here also we have to add all elements on the transition functions, that means dou of Q comma epsilon. Then only your epsilon closure will convert the recursive definition. Thank you.